Welcome to the DIY Honda Garage channel. Welcome to our diagnostic guide for DTC P0523, which signals an issue with the engine oil pressure sensor circuit displaying high voltage. This trouble code, DTC, indicates that the engine oil pressure sensor output voltage has exceeded specified limits, prompting the powertrain control module, PCM, to store this error code. The engine oil pressure sensor plays a crucial role in monitoring the lubrication system by providing real-time data about the oil pressure levels, ensuring that the engine is properly lubricated. The sensor is typically located near the engine block, allowing for accurate pressure measurements directly within the lubrication circuit. When the voltage is detected to be higher than expected, it may result from a variety of issues, including sensor failure or wiring problems. By following the diagnostic steps outlined in this guide, you can accurately identify and resolve the problem, restoring normal function to the engine lubrication system. The error described by DTC P0523 pertains to the engine oil pressure sensor, which is responsible for relaying oil pressure information to the vehicle's PCM. This sensor is critical for ensuring that the engine receives adequate lubrication, which directly affects performance and longevity. The engine oil pressure sensor is typically installed on or near the engine block, positioned so that it has a direct assessment of the oil flow. When the input voltage from this sensor exceeds a specific threshold defined by the manufacturer, the PCM flags this condition as a fault. This abnormal voltage reading signals that there might be an issue with the sensor itself, the wiring circuit connected to it, or potentially the PCM. Addressing this error quickly is essential to avoid serious engine damage due to inadequate lubrication. Several factors could lead to the triggering of DTC P0523. Firstly, a faulty engine oil pressure sensor is a primary suspect. If the sensor itself is malfunctioning, it may incorrectly report higher voltage levels than actually present. Secondly, issues within the wiring harness, such as damaged wires or poor connections, might also lead to erroneous readings being sent to the PCM. Additionally, there could be a fault within the PCM itself, which manages and interprets signals from various engine sensors. Each of these components plays a crucial role in the integrity of the engine's operation, and any failure could lead to severe engine issues if not addressed properly. Conducting a thorough inspection following the diagnostic procedures can help pinpoint the exact cause. The symptoms associated with DTC P0523 can manifest in several ways. One of the most immediate indicators is the presence of a warning light on the dashboard, alerting the driver to an engine issue that needs attention. Additionally, there may be noticeable engine performance problems, including fluctuations in power output or poor acceleration, as the engine may not be receiving adequate lubrication. In severe circumstances, if the oil pressure is truly low due to sensor failure or another cause, this can lead to engine overheating. It's critical to address these signs promptly to prevent potential engine damage. Regular monitoring of oil levels and pressure can help avoid such alarms, making early intervention possible. The first troubleshooting step for diagnosing DTC P0523 involves turning the vehicle's ignition to the on position. This allows the onboard diagnostic system to initiate and check the performance of the engine oil pressure EOP sensor. Utilizing the Honda Diagnostic System, HDS, you will monitor the rocker arm oil pressure sensor voltage value. According to the diagnostic information, if this voltage exceeds 4.79 volts, it indicates a direct correlation to the fault stored in the PCM as DTC P0523. It's essential to understand that normal conditions require the value to be less than this threshold. This step serves as an initial confirmation procedure, to determine if the problem lies with the sensor output or with another component of the engine management system. The second step involves a hands-on inspection of the engine oil pressure sensor itself. To start, you need to disconnect the 3P connector from the sensor to safely perform the next check. Following this, the next action is to use a jumper wire to connect terminals number 1 and number 2 on the engine oil pressure sensor connector. This procedure allows you to simulate the sensor output and check for the expected voltage levels while the vehicle is in the on position. As you monitor the HDS for the rocker arm oil pressure sensor voltage, it is crucial that the reading stays within the normal parameters. Anything lower than 4.79 volts indicates that the oil pressure sensor is functioning properly. Thus, if an abnormal voltage is detected, it suggests a possible failure of the engine oil pressure sensor. The third step requires disconnecting the PCM connector B, ensuring that all necessary safety precautions are taken prior. Prior to disconnecting, be sure to use the HDS to jump the SCS line and wait for a minimum of 1 minute to properly reset the system. With the engine oil pressure sensor connector still disconnected, you will perform wire inspections based on the diagnostic table provided in the manual. These inspections include checking the OPSEN open wire and the SG2 open wire connections, ensuring that each shows less than 1 ohm of resistance. If either wire shows a higher resistance value, this indicates a circuit issue that may be causing the high voltage reading. By inspecting and ensuring that all connections are in good condition, you will eliminate potential wiring faults as a contributing factor. The final troubleshooting step is to inspect the PCN function if all previous inspection items have indicated normal conditions. At this point, if the sensor and wiring have been confirmed operational, it leads to the potential conclusion that the PCM itself may be faulty. The PCM, or Powertrain Control Module, serves as the vehicle's primary computer, managing a plethora of critical functions, including engine performance, emissions control, and sensor data interpretation. A malfunctioning PCM can lead to misleading sensor readings, including the erroneous high voltage from the engine oil pressure sensor. Determining whether the PCM is at fault involves various tests and comparisons of operational variables. If a fault within the PCM is confirmed, it may need to be reprogrammed or replaced altogether to restore normal functionality. After completing repairs, the next critical step is to clear the DTC from the vehicle system using the HDS tool. This allows the PCM to reset and begin the monitoring process anew. It is vital to conduct a thorough road test to ensure that the repair was successful and that the engine oil pressure sensor and related components are functioning within the norms. During this test, closely monitor the vehicle's performance and the dashboard indicators to catch any signs of returning issues promptly. Observe values for the rocker arm oil pressure sensor to confirm that they remain within the desirable range under various driving conditions. Successful verification will lead to a resolution of the trouble code, confirming the effectiveness of the applied corrective measures. Preventive maintenance plays a crucial role in avoiding the recurrence of DTC P0523 and potential engine reliability issues. A vital aspect of this maintenance includes regularly checking the engine oil levels, ensuring that the oil is always within the recommended range. Low oil levels can cause the oil pressure sensor to react abnormally, triggering DTCs. Routinely inspecting the wiring connections associated with the engine oil pressure sensor can help detect early signs of wear or damage, allowing you to address any issues before they progress. It's advisable to periodically check and replace the engine oil pressure sensor as part of the scheduled services to maintain optimal engine performance and enhance the longevity of related components. By consistently practicing preventive measures, you can greatly reduce the chance of encountering similar issues in the future. In conclusion, understanding the root causes of DTC P0523 is essential for effective troubleshooting. This error primarily relates to the engine oil pressure sensor circuit reporting high voltage, indicating potential faults in the sensor or associated wiring. By following the detailed diagnostic steps outlined in this guide, you can systematically isolate the problem, ensuring the timely restoration of engine performance. It's worth noting that preventative maintenance is crucial in reducing such incidences by regularly monitoring oil levels and maintaining connections. Additionally, frequently checking component conditions can help catch potential failures early. Taking a methodical approach will not only help you resolve the current code, but also enhance your overall vehicle maintenance strategy for the future. Please like and subscribe to the channel. See you next time.